Right, everything's in place. Well, you can just close the door, please, for me, just in case there's a whole bunch of noise coming in. All right, so here we go, direct proportion. And we've already talked about this, about the conversion graph between miles and kilometres, or kilometres, however you pronounce it. And let's put some more in. If we double the miles to 10, then we double the kilometres. So if we times 2 times 2, this is now 16. We could also times by 3. We could also then times by 3 here. So this will be 15, and this is 24. So you can see that just doubling and tripling, the numbers actually stay in the same ratio. So this ratio is 5 to 8. 5 miles to 8 kilometres. This is 10 to 16, which simplifies back down 5 to 8. This is 15 to 24, which simplifies as a ratio back down 5 to 8. Now you can actually go backwards the other way. What if we actually did divide by 5 here to get 1? Then this also would have to be divide by 5. Now this is where you might just want to get out your calculator. 8 divided by 5, I can do that in my head, 1.6. So there is the conversion rate. 1 mile becomes 1.6 kilometres. So therefore, take the number of miles, times it by 1.6, and you get the kilometres. All right, there's your conversion. So if you can get down to 1 mile, then you can see what the conversion rate is. Now I'm going to do that a slightly different way now from the graph. So let's plot on the graph. I'm going to plot a couple of points, and then I'm going to join up with a straight line because I know it's directly proportional. So these 2 points here, let's get them on the graph. 5 is 8, and 10 is 16. And we know it goes through the origin, so we've got this kind of lovely conversion graph. That second point was plotted terribly. So there's my conversion graph, which would be beautiful. But let's also put a point on here. This is 5, 8. Now watch the magic of the calculator. If we get it out, if we do 8 divided by 5, strangely, 1.6. What if we do 16 divided by 10? Answer? 1.6. What if we do 24 divided by 15? 1.6. What if we do 1.6 divided by 1? Exactly. What if we take any kilometres and divide it by its equivalent number of miles? What do we get? 1.6. So look down here, guys. What if we take any y on the graph and divide it by its x partner? What do we get? We get the 1.6, and this is the 1.6, the k, which is the constant of proportionality. So let's write down the equation. Y equals 1.6 times by x. Just have a little look at that equation. Compare it to this. Y equals k times x. The k is the constant of proportionality. And how do we get k? Take the y value, divide it by the x value. Let's try it from the graph. Here's the y value 8. Here's the x value 5. 8 divided by 5 equals 1.6. You guys know this in a slightly different version. Watch the magic, because what we've actually done there is just found the gradient. Look. This here, the red, tell the person next to you, how long is that red line? Tell the person next to you. And then also work out the length of the blue line. Did you get it? So the red line is 8, and the blue line is 5. And 8 divided by 5 is the gradient. It's rise over run. In science, you might call it delta y, the change in y, delta x, the change in x. Okay? So that's rise over run. 8 divided by 5 is 1.6. This is the rate of change. You guys know all that, right, from maths and from science, but when you see it all come together, that should be helpful. So this is direct proportion. Miles times 1.6 is kilometres. or y equals 1.6 times by x. Now on to the next page. I'm going to introduce slight new language. And if you have a little look here, y is directly proportional to x. Well, that becomes this equation, right? And it looks like this as a graph. All right, so all those three phrases are strongly connected. But then there's this other weird thing. Now tell me if you recognize this symbol. Okay, this is a proportional symbol. So this actually, mathematicians and scientists like to use as few words as possible, I think, right? If we can draw a graph and use symbols, I think for maths and scientists, a little bit better. Because language can be quite confusing, especially if you're learning English as a second, third, or fourth language, right? But this says y is proportional to x. Y is directly proportional to x. So that symbol means that as x goes up, y goes up. So the little thing in black on the screen is good, but then better is actually to write it down as this equation connecting y with x. Grace, question?
What is that little wiggly?
Yeah, it's a wiggly symbol. It's like a fish. This is the symbol of proportionality. Okay, so now let's look down at the graph. If we read the graph, on the x-axis, if I make it a bit bigger, is the mass in grams, and on the y-axis is the extension of a spring. So can you see it goes through 0, 0, which would make sense. There is 0 grams on the end of a spring, therefore it's not going to extend anything. But then as soon as you put some grams on, there's a natural extension, right? But the extension stops at some stage, doesn't it? What happens in an actual experiment? What if I put 100 kilograms on? Does it just keep extending?
No.
What happens?
It extends to a certain amount.
To a certain amount, and then what? It stops. How does it stop? Snaps. Right? It snaps off, doesn't it? You imagine, can't you? A spring's just metal. As soon as it gets to its limit, it's just going to be pulled apart. Okay? But over a certain particular mass in grams, it's going to follow this beautiful pattern. So if you did this experiment, you might get some points that would look almost perfect like a straight line. And then in maths and science, we create a nice model, a line of best fit, and it would look something like that. Tell the person next to you, how am I going to get the equation of this line? How am I going to get the equation of this line? Tell the person next to you. You've got 10 seconds.
Y is on the left and y. Yeah. So what you would have to do is you would have to times something, and then y.
All right then. So notice I've written down the rule, y equals kx. We know it's directly proportional. We know this rule is going to work for this, right? And k is the posh word for k? No, not in this context. K is, Marlena, you got it written down? Constant of proportionality. Constant means it doesn't change. So whatever the value for k is for this graph, it's going to work for all the values on the graph. And how do we find k?
By timesing the values by 1.6.
At 1.6 was the k for this.
So timesing the
Down here, guys, look. Here's how we find k.
y.
Take an xy pair of numbers, and the k value is what do you multiply x by to get y? Another way of doing it is just doing y divided by x. Okay, so have a look at those two rules on there. So the k is the thing you multiply x to get y. How do you get from x to y? And the simple way of working it out is just take y and divide it by x. So off we go to here. I am going to pick out a really nice coordinate that I can clearly see. Not one that's kind of halfway through a square. I pretty much am sure that this point here works. So this one here is 4, comma 6. You've got 10 seconds. Find k for me.
Mr. Stewart,
Yeah.
wouldn't it be 6,4? Or is that 0.6?
X followed by y. X followed by y. Always. So we're consistent. No, it's not 0.6. Find k for me.
1.5?
It is 1.5. Why is it 1.5?
Because 6 divided by 5.
K equals 6 divided by 4. From the pictures before, it's the rise over run, or delta y divided by delta x. So therefore it's 6. Oh, that's funny.
Mr. Stewart,
1 second, please.
okay.
So it's 6 divided by 4. 6 here and 4 here. So our rule at the bottom, we can replace that k now with a cheeky 1.5. Question?
So if x followed by y, so it's 4, 6.
Yeah.
Then why don't we do 6 divided by 4?
We
not
did.
4 divided by 6.
Because 6 divided by 4 is 1.5. And then just try it out. Ready?
I
So,
can't-
no, let me show you. Let me show you, okay? Take this value, 5.
Yeah.
This is the next value. What do we multiply it by to get its y partner?
7. No.
No, the rule is just down here, right? So we need to multiply 5 by something to get all the way up here to get its y partner. And you see this x here?
Yeah.
We need to multiply x by something to get all the way up here to its y partner. Go back to the table here.
Oh, wait. Can I use your calculator?
Yep. Go back to this table here. Can you see that when we were looking at the 1.6, the magic 1.6, the 1.6 tells us how to get from the miles to kilometres, from the 10 to the 16, from the 5 to the 8, from the 1 to the 1.6. All right? So if you do the division the other way around, Toby, if you do 4 divided by 6,
0.6.
you get 0.6666. Now that would be a rule moving from y back to x. Mathematicians and scientists love saying we take the x number and we do something to it to get the y number. Who has heard of dependent and independent variables? This is why we always do something to the x to get the y. Now think about this particular experiment. Which of those two variables has an impact on the other variable? Is it, do we kind of have some extension and then that determines the weight, the mass on, or as we add more mass on, that becomes more extension? Which way around is it? Yeah. Sophie? Yeah?
If we add more mass on it, the extension.
Okay. So in science terms, the mass is the independent variable and the extension is the dependent variable. So the extension of a spring depends on the amount of mass you put on. Okay, so Toby, you could have it the other way. You could have the rule going the other way, but whatever is the driver goes on the x-axis. So mass is always on the x.
My reason was if it's 4 over 6, then people get confused because if you time it 6 times 4.
Yep, it would be confusing, yeah. So, and again, mathematicians love consistency. So it is always the y divided by the x. And then if we all are consistent by putting the right variables on the correct axis. Final page, guys, you've been superb. Let's have a little look at this. A lot of language going on here, which is challenging. And let's just go and zoom in on it. This is some kind of taxi thing, and I'm zooming straight to this. $2 for 3 minutes. $2 for 3 minutes. So I'm going to go straight to a table. And this is okay. Now look at the way I've done this. See, I've put the time in minutes first because I think that's on the x-axis. Would it make sense that the cost of a ride depends on the amount of minutes you've spent in the taxi, right? There's other things, right? Waiting time, how many bags you put in the back, whether you get picked up from a premium location. There's lots of other variables, but the main variable is how long you're actually in the taxi. It could be the distance you travel as well, right? But the more distance you travel, the more time you're in there. So time, I think, is the X variable, and cost is the Y variable. So let's just do some numbers in here. What if I double the time to 6? What would happen to the cost? It would double. All right? And what if I times the time by 10 now? Yeah, so this is direct proportionality. But now let's put the 3 down here and the 2 here again. And now let's write down Y equals K times by X. The cost equals K times by the time. And now let's work out K. All right, each table gets a different number to work out. The end table there, Grace's table, you're going to use the 3 and the 2 to work out K. Toby's table, you're going to use the 6 and the 4 to work out K. And Harry's table here, you're going to use the 60 and 40 to work out K. And the final table, you are going to use 30 and 20, because they're just times by 10. All right? So off we go, and let's work out the K. For those of you wondering again, all the way back to here, there's K.
So basically, I think because if they want 6, 4, right? 50, right? So will it be 4 times 6?
And Grace's table. What did you do with your numbers, and what answer did you get?
3 divided by 2.
3 divided by 2 is incorrect. Toby's table, what did you do?
It's
Hold on.
why not?
If they're not correct, then you can put.
Harry's table, what did you do with your numbers?
We did 40 divided by 6.
40 divided by 60 is correct. The Y value divided by the X value. What did you get? 0.66666666666666. So let's round it up to 0.67 to 2 dp. Yeah? K is 0.67. Now let's interpret what that number actually is. Watch the magic now. If I delete this last little bit here, I will show you exactly what that means. Take this 3 and take this 2. I want to know, how do I get down to 1 minute for this taxi ride? 1 minute. Can you see from 3 minutes down to 1 is divide by 3? So therefore the cost is also divide by 3. 2 divided by 3 on your calculator is 0.67 to 2 decimal places. The rule here is cost equals 0.67 multiplied by the time. And now the magic that is that 0.67, this 0.67 is the constant of proportionality. I think for this though, more importantly, it's the rate or the gradient. It's 0.67, 67 cents for every 1 minute. So this magic number is telling you for every 1 extra minute how much extra cost. Back here, this tells you, the 1.5 tells you for every 1 extra gram how many centimetres extension. And back here, the 1.6 tells you for every extra 1 mile how many extra kilometres. So that K value, the constant of proportionality, or the rate, is how much in the Y for every 1 in the X. What questions might you have, guys? So I'll leave it there on the big screen. I'm going to go and pause this now.